One of the oldest truths in geometry is the Pythagorean Theorem, which is named for the Greek mathematician Pythagoras, who lived over 2,500 years ago. Now actually, this truth was known long before Pythagoras, but he may have been the first to prove the theorem. Okay, so here it is. Given a right triangle, vertices ABC with a right angle at C, and sides lowercase a, b, c, with the sides opposite the corresponding angles, then a squared plus b squared is equal to c squared. In other words, if you square the lengths of each leg and add that up, the answer you get will be the square of the hypotenuse. So here's the diagram again. Okay, so A, B, C, if we square the length of each leg, add them up, we get the square of the hypotenuse. Okay, so for example, we have A equals 6, B equals 8. Find C. Well, all we need to do is substitute into the formula. If A is 6, then A squared is 36. B is 8, then 8 squared is equal to 64. Add the two up, we get 36 plus 64 is 100. Therefore, we have C squared equals 100, so C is equal to 10. Let's look at a few more examples. We have A equal to 3, B equal to 4. We need to find C. Okay, so remember we have A squared plus B squared is equal to C squared. Pythagorean Theorem. So substituting in, we have 3 squared plus 4 squared. That's 9 plus 16 is equal to 25. That's C squared. Therefore, C is equal to what? 5, right? Okay, next example, we have A equal to 5, B is equal to 12. This time we have 5 squared plus 12 squared. That's 25 plus 144 comes to 169. Now, possibly you may not know what the square root of 169 is, so let's do that on the calculator. On my calculator, I have a square root button right here, and you probably have a similar key on your calculator. So square root 169, the answer is 13. So C is equal to 13. Okay, next example. Now we have A equal to 8 and C equal to 17. Now this is a little different now, isn't it? Before we were given A and B and had to find C. Now we're still using the same formula, but we have A and C given and we need to find B. Okay, so let's just transpose the A squared to solve the equation for B squared, and that will give us subtracting a squared from each side, gives us b squared is equal to c squared minus a squared. Okay, so now we can plug in 17 squared minus 8 squared, that's b squared. So b squared is 17 squared, that's 289, minus 8 squared is 64, minus 64, and we have 225. Okay, now remember that's not the answer, this is b squared here. And if we want b, then we need to take the square root. b is square root 225. The answer is 15. Now, in all of these examples, the answer turned out to be a whole number. But of course, that will not always be the case. There will be many times when you apply the Pythagorean theorem, the answer is not a whole number. And in this case, then we can either give our answer as a radical, or we can give a decimal approximation. Okay, so for example, we have a equal to 5, b is equal to 7. Find c. Okay, so substituting in, we have 5 squared plus 7 squared. Okay, so that's 25 plus 49, and that is 74. Well, 74 is not a perfect square, so that means c is equal to root 74. And if we want an approximation, we have to go back to our calculator. Square root of 74. And the answer is approximately 8.6. So we can leave our answer in either of these two forms, and usually either one is acceptable. Okay, now we have a equal to 3 and c equal to 8. We need to find b. Okay, so this time we need to have the b squared on the left-hand side. So c squared minus a squared this time. And we have 8 b squared is equal to 8 squared minus 3 squared. So that's 64 minus 9, or 55. So if b squared is 55, then b is equal to root 55, which is approximately 7.4. Okay, let's do just one application. In AC circuits, an important consideration is often the impedance of a circuit. And impedance can be calculated from resistance, which is resistance that we're familiar with from DC circuits, and reactance, which comes from the other components, the capacitors or inductors, reacting with the AC voltage. And reactance is represented typically with the letter X. It turns out that resistance and reactance can be thought of as the legs of a right triangle. And in this case, then the hypotenuse will be known as the impedance. And therefore, we have, in any AC circuit, r squared plus x squared is equal to z squared. And you should see that this is nothing more than the Pythagorean theorem written with r and z replacing a and c and x replacing b. Okay, so for example, we have R equals 670 ohms, X equals 420 ohms, and we want to find Z. Okay, well, this is exactly the same as what we were doing before, it's just the letters are different, right? We have R squared plus X squared is equal to Z squared. So we have 670 squared plus 420 squared. And of course, we need our calculator for this. 670 squared plus 420 squared equals, and then I need to take the square root of that to get the answer. And the answer is about 791 ohms. And usually we will round answers off to the nearest ohm, or possibly even less precision. Don't bother writing 5 decimal places for answers like this. You're not going to find better precision in a resistor anyway.